The broadcast is now starting. All attendees are in listen-only mode.
Welcome. Thank you so much for joining us. This is the California Water Plan Update 2013 Groundwater Webinar number 3. Today we're going to be doing a review on the hydrologic region enhanced content that was done for California Water Plan with a focus on Tulare Lake, San Joaquin River, and Central Coast hydrologic regions. My name is Lisa. I'll be your moderator today, and I'm going to go ahead and turn this over to Gavechi to tell us about what is planned for today.
Very good. Good afternoon. This is Gavechi. I'm with the Department of Water Resources. I manage statewide integrated water management, and I've been working on the California Water Plan for the last 14, 15 years. As we were, so first of all, thank you for all joining us. This is a second webinar in a series of the enhanced groundwater information content in the California Water Plan Update 2013. And when we were scoping for Update 2013, one of the things we heard loud and clear from stakeholders is that the California Water Plan needs to have more information on groundwater and to show how it is part and parcel of an integrated water management approach. And we took heed to that advice, and we convened a Groundwater Caucus that was co-chaired by Abdul Khan and Dan McManus. And it was probably the largest and most well-attended of the caucus group topic caucuses that we had for Update 2013. As a result of the work of the caucus and a number of DWR staff and other state agency staff, we developed a significant amount of new information on groundwater that is part and parcel of the water plan. As the water plan has been out since last fall, DWR staff felt that it would be really convenient to pull all that content together into a compilation report. And we have done that, and the statewide chapters of the report were presented in an earlier webinar. And what today's webinar is the first of several webinars on the regional chapters of the compilation report. And as Lisa mentioned, today we're going to focus on the Tulare Lake, San Joaquin River, and Central Coast hydrologic region chapters. This is very important, and you're going to information, and what you'll hear today later on is how this information will help DWR and others develop the interim Bulletin 118 update in 2017, as well as information that is being used to implement the Sustainable Groundwater Management Act, as well as the Governor's Water Action Plan. So again, thank you for joining, and I'm going to then turn it back to you, Lisa.
Well, great. Well, thank you so much for giving us that overview. Next up is going to be Dan McManus, and he's going to talk to us about the groundwater update overview. So with that, we're going to turn this over to Dan.
Okay, thank you, Lisa and Camiar. Can everyone see the screen?
Yes.
Okay, great. All right, well, yeah, my name's Dan McManus. I'm the co-lead on the California Water Plan Groundwater Enhancement effort. Abdul Khan is the lead in this project. This is the third in the series of 6 webinars we'll be hosting to present our report findings. For today's presentation, I'm also joined by Mark Norberg, a senior engineering geologist who's provided significant contribution in the preparation of this report. Other members of the project team, Roy Hall and Mike McKenzie, are also joining us today to help answer questions as needed. I want to start off today's presentation by a couple quotes from DWR directors, both past and present. In 1957, Harvey O. Banks stated that groundwater looms very large in the total water picture in California, and the formation and implementation of plans to meet our needs for water in the future. We are seriously lacking in the data and the groundwater information necessary for a planned utilization of groundwater. About 35 years later, in 2014, our current director, Mark Cowan, said, "Today, it's all the more all the more apparent that we need to change the trajectory in terms of our ability to understand groundwater and take bold actions to manage it sustainably. Now, although somewhat overdue, we believe that our 2013 groundwater update presents a modest attempt to fill this void and provide some additional groundwater data and information highlighted by both these directors, both past and present. So the groundwater team, as Camille mentioned, the report represents a large team effort. The contents were developed using the resources, tools, and data compiled and analyzed by experienced DWR staff from our regional offices under the Division of Integrated Regional Water Management and by our staff from the Division of Statewide Integrated Water Management. Camille also mentioned the Groundwater Caucus. Our team used the collaboration outreach process in the California Water Plan to form a groundwater-based, topic-based Groundwater Caucus. The Groundwater Caucus provided some significant input on the compilation, the synthesis, and the presentation of the groundwater information. The caucus consisted of over 60 members representing a broad range of interests from ag, urban, and environmental water managers, and members of the state, federal, and local agencies. This slide shows a chronology of groundwater content in the California Water Plan starting in 1957. And as you can see, with each update, as groundwater use in California has increased, the extent of groundwater content in the plans also increased. And although in 2005 and 2009, those updates, we provided the addition of some important groundwater resource management strategies, some of the feedback and comments received after the 2009 update indicated that additional groundwater information is still needed for future California Water Plan updates. So once again, the 2013 California Water Plan groundwater update really attempts to fill that void by significantly improving the level of groundwater information based on previous reports. So the main goals, we have three main goals. The primary goal really was to improve the statewide and regional understanding of groundwater conditions and management practices. We feel that the collection, the processing, and reporting of the groundwater data in the 2013 update will really help set the stage for future versions of the both 118 updates and to help our local agencies plan for sustainable groundwater management by providing a regional compilation of the essential groundwater data analysis and recommendation. The second goal is to identify the data gaps and groundwater management challenges. And we feel that the identification of the groundwater data gaps will really help serve as a guideline to help prioritize future data needs and funding opportunities. And then lastly, our third goal was to develop recommendations to improve groundwater management in California. As far as the report organization goes, the report starts off with the findings, data, gaps, and recommendations, followed by Chapter 1, which provides the introduction, scope, and future directions, and then Chapter 2, which is a statewide update and summary of the groundwater data. The subsequent chapters, Chapters 3 through 12, are organized by hydrologic region and really provide a kind of a standalone report of the groundwater data analysis and recommendations for each of these 10 hydrologic regions. We also have a fairly robust technical appendices. The appendices includes additional detailed information regarding the methods and assumptions, the CASGEM Basin Prioritization, the groundwater use data, conjunctive management survey results, changing in storage data, and also some land subsidence references. With respect to report content, we've developed a report based primarily on the groundwater information that was readily available. We didn't go out and do a lot of additional studies for this particular report. And because of this, the level of groundwater information is somewhat variable for each hydrologic region. However, as a whole, we feel that each hydrologic region report really serves as a fairly comprehensive standalone report for each of the subject matter categories. Organization material is presented in somewhat of a logical progression of topics, similar to what you might find in a existing conditions report. First, we looked at the groundwater supply with respect to the source of the groundwater supply, and with that I mean the alluvial aquifers, fractured aquifers, the existing well infrastructure, and also in context of the basin prioritization. And then we looked at the average groundwater uses and change in groundwater use by region and by type of water use, and that was broken down into ag, urban, and managed wetlands. And then in Section 5 of the report, examined the extent of groundwater monitoring efforts with respect to groundwater levels, quality, and land subsidence. Section 6 of the report takes a look at the Aquifer's response to those existing groundwater demands and management practices. We look at the occurrence and movement, depth of groundwater, groundwater elevation, level trends, change in storage. We have some information on quality and land subsidence. And then finally, sections 7 and 8 present the results of an inventory and assessment and survey of the groundwater management and conjunctive management activities for each of the hydrologic regions. Now I'm going to turn the report over to, or this presentation over to Mark Norberg, who will show kind of a snapshot of the groundwater information for the Tulare Lake, the Joaquin River, and the Central Coast hydrologic regions. And let me see if I can, so I should transfer this to, oh, you got it. All right, thank you. Mark, are you on?
Here we go.
Oh, sorry, we were muted. Thanks, Dan, for kind of setting the stage for what we're going to talk about for the next 45 minutes. You know, as Dan just indicated, there is a substantial amount of content that goes into each of these reports, and the way it was designed was for these reports to be, you know, standalone documents. You know, the three that we're going to talk about today, and I'll talk about them generally in this order: Tulare Lake hydrologic region, followed by Joaquin River and Central Coast. There's so much content, but for this particular presentation, you know, we're going to focus on, you know, the well infrastructure and the distribution of those wells, some monitoring well information, you know, specific primarily to groundwater elevation monitoring. We'll discuss basin prioritization, an overview of groundwater quality and where you can get information, you know, lots of details about groundwater supply and aquifer conditions, and then ultimately follow up with groundwater management. You know, but before I get started, I want to just reiterate again what Dan said. You know, this really was a all DWR effort to compile this information, to present this information, to develop the graphics, you know, and just to organize and edit these documents, which, you know, our editors are doing right now. These three hydrologic regions are all within the boundaries of our South Central Region office in Fresno. So I want to give a, you know, thanks to Dane Mathis and John Kirk and Mike McKenzie and Mike McGinnis, you know, for all the help that they did in this. I would hope everybody has for those hydrologic regions they're interested in, you know, download the reports, print them out, because far more details, you know, with respect for alluvial aquifers, land subsidence information, you know, and other detailed groundwater information are in those reports. But we'll start with well infrastructure and distribution. I'll talk about it first on a statewide level. This presents the same information in three different ways. They're broken out in this particular way by hydrologic region, and for the bar chart in the lower right, I kind of starred those bars that are represented by the hydrologic regions we're talking about today. But we'll start off in the upper right-hand corner. It's a pie chart of all the wells that the department has a record of. And we kind of grouped this between 1977 and 2010. Your records prior to that weren't as complete, and, you know, we determined that at least starting with 1977 was a good place to start. But there's a requirement for drillers to provide to the department well completion reports, and I'll get into that in a second. But for what the region offices have available to them, we've got about 432,000 wells on file, you know, through 2010. This pie chart right here kind of gives you an indication of how many of those wells are indicated on the well completion reports to be domestic wells or irrigation wells or public supply wells, you know, which are for industrial purposes, which are specific to monitoring, or other wells. And those other wells are, you know, like stock wells or test wells, or just simply those wells that are unidentified on the well completion reports. So this kind of gives you a breakdown of all those categories by type. You know, and as you can see, obviously, most of the wells on record are domestic wells. Only 10% of those are irrigation wells. However, one thing to keep in mind, you know, the pumping rates of domestic wells are kind of in the tens of gallons a minute. For irrigation wells, you know, they're going to pump more like hundreds or thousands of gallons a minute. The information below the pie chart here, I believe you can see me moving my mouse. These are the statewide number of well logs by type and hydrologic region. you can see with this bar right here, the Sac River has the most number of wells at about 108,000, and the North Lahontan has the fewest number of wells on record with about 4,000. But the ones we're talking about today are the San Joaquin River right here. Oh, that's interesting.
That's you. Go ahead, keep going.
You're going to make me talk like this?
Yeah, they want to see who's talking. So, yeah, I'll take it away if it's distracting.
Thank you. So now I'll have to look at my notes. The hydrologic region, thanks, Lisa. Talk about throwing a guy off his game.
Well, you know what? You're doing a great job.
So we'll look at we'll focus on the details for the hydrologic regions in a second, but this just gives you an indication of which hydrologic regions has the most wells and what type they are. And again, you can see that domestic wells for most hydrologic regions encompass the most number of wells. This breaks it out by year, and it's the bar chart. It's pretty busy on the lower left, and it starts in 1977 and it goes through 2009. It goes through kind of a cyclic approach to what type of wells are installed in which particular year. The light blue on the bottom there, that's domestic wells. The red on the top is irrigation wells. And you could definitely see in drought years, we start in a drought year in 1977, lots of domestic wells, lots of irrigation wells, and far fewer of those particular wells drilled in wet years. So now we'll go on and kind of talk about this region by region, graph by graph. And these are well logs by type. And again, this goes from 1977 to 2010. And the requirements for wells to be given to the department are identified in Water Code section 13751, which says, drillers who construct, alter, abandon, or destroy wells are required to submit a well completion report to DWR within 60 days. Sometimes we get those, sometimes we don't. Also of note is Water Code section 13752, which currently holds those well completion reports confidential with some exceptions. We'll start on the top. Again, this breaks it down by hydrologic region, about 54,000 plus wells in the Tulare Lake region. Over half those are domestic wells, and about a quarter of those are irrigation wells. Down in the San Joaquin River region, a greater number of wells, almost 74,000 wells. And again, a higher percentage of domestic wells. Still a good percent of irrigation wells, but keep in mind, again, those irrigation wells pump a large amount of water with respect to domestic wells. And again, fewer wells in the Central Coast region, almost 31,000 wells. And again, over half those wells are domestic wells. Now we're going to look at those wells that are grouped by hydrologic region by county. And we kind of had to not include all counties that touch that hydrologic region, but include those counties where most of the county touch the hydrologic region. So for example, and the one thing I want to point out as well is that the vertical scales are different. So right here in the Tulare Lake region, the top scale is 28,000, 12,000 for the Central Coast, and 14,000. So these aren't comparing each other by scale, but you can see county by county within each region kind of which wells are most prevalent. The Tulare Lake region, Fresno County has the most number of wells, and quite a few of those are domestic wells and irrigation wells. In the reports themselves, there's detailed tables that give you the numbers. The numbers are approximations. They're not an exact number of wells, but they are coming from the records that DWR does have on file. You can see here down in the Central Coast hydrologic region, San Luis Obispo County has the most number of wells, and then over in the San Joaquin region, it's Madera County has the most number of wells. And again, you can see in most of these areas, domestic wells and irrigation wells, with some exception, are the most common type of wells. Now we'll look at the same well type, however, look at the year installed. And again, the x-axis here on all the wells is consistent, 1977 to 2010. But again, the vertical scale is different. 4,000 up here for Tulare Lake, 1,800 for Central Coast, and what is that? It's off the screen, but it's That's off my screen as well. Quite a few for the San Joaquin River as well. A couple things to note here. Once again, kind of a cyclical fashion, more wells drilled when it's dry, fewer when it's wet. Again, 1977, a historic drought year. Look at the Tulare Lake region. Half the wells drilled were domestic wells. Almost half the wells were irrigation wells. I do want to point out, and this goes for all of these three regions and all the records that the department has on file, I wouldn't rely upon the last couple years, 2009, 2010. There generally is a lag time that the department has in receiving these well logs and processing these well logs. So as we update these particular charts for the next iterations of, be it a water plan or Bullet 118, these kind of end bars will change probably dramatically. But it just goes to show you in what type of water year, what type of wells installed. There's some interesting notes, and probably all of these, kind of in the early to mid 2003, 4, 5, 6, 7, the increase in domestic wells may not necessarily have been due to climate conditions, the amounts of precipitation, but more for housing booms, for example. And again, far more details in the report. So now we'll kind of take a switch. We talked about all the different types of wells that there are available and that need to be submitted, or well completion reports that need to be submitted to the department. Now we'll focus on just those groundwater level monitoring wells. And this information is active, I believe this goes through July of what, 2012? This figure on the left shows, again, those monitoring wells, the groundwater level monitoring wells, whether that data comes from domestic wells, irrigation, observation, public supply wells, or other wells. And there's about 10,800 of those particular wells. The same information then is translated onto this other map on the right, and it shows who's collecting that information. Be they wells from the CASGEM program, various monitoring cooperators the DWR has that gives information to us, whether they're collected by DWR itself, USGS, or the Bureau of Reclamation. So these aren't all the wells. I want to make sure this point is understood. These aren't all the wells that are out there, monitoring wells, for example, but these are the wells that are publicly available. There are likely gaps in here that you'll identify where there's monitoring going on. However, that monitoring is not at the time publicly available. CASGEM, the purpose of that program is to make publicly available groundwater elevation monitoring information. And since the information was pulled onto these these figures, the CASGEM density of wells is increased quite a bit. I'd highly recommend folks look at the CASGEM site to get a full indication right now of what's being monitored under CASGEM. So now I won't go into an extreme detail because you can read the reports and you can look at these figures in a little bit. We'll make the PDFs of these slides available soon. But you could say of the wells that are being collected or that are collecting groundwater elevation data in the Tulare Lake region, quite a few of those wells, more than half of those wells are coming from other type of wells, which generally means we don't know what their use is. And if we don't know what their use is, there's a really good chance we don't know what the construction information is. And so you're not really able to definitively say, if this particular well is monitoring a shallow unconfined system or a deeper confined system. But again, it kind of indicates numbers of what type of wells the data is collected from and who's collecting that information. Onto the San Joaquin River, once again, let's see how many were there in Tulare Lake. About 3,300 plus wells as of July of 2012. I'm sure that number has increased. I don't know what it is currently. But about half the number of wells are being monitored for elevations in the San Joaquin River. And again, there's different densities of different wells, and it generally reflects the type of management and monitoring that are going on in those particular areas. Most of the monitoring of elevations is done within the Central Valley, but there are some areas outside the Central Valley, what would be a fractured bedrock system that are collecting information for whatever the purpose might be. And then on to the Central Coast region. Again, when we did the data dump for this particular figure, 817 wells we had on file. And again, quite a few of those wells are other type of wells, which means we probably don't have a whole lot of really good construction information, depth of the well, screen interval of the well, or even some general lithology that's generally identified on the well completion reports. So you can read a lot more details in the report, and in the interest of time, I'll continue moving. One thing I will point out here is maybe some lack of information in the Salinas Valley, for example. At the time that the data was pulled for these reports, again, it goes back to publicly available data. And I checked just the other day, and I know that most of the areas, if not all the areas in the Central Coast hydrologic region, are now CASGEM compliant. Speaking of CASGEM, we'll now talk about basin prioritization. One of the intents of CASGEM were to make publicly available groundwater level information for all of California's 515 alluvial basins and subbasins. When I say alluvial basins and subbasins, if you're thinking the Sierra Nevada or the hard rock areas of coastal ranges, those are outside of the alluvial basins and weren't a requirement for data collection with respect to CASGEM. But the other thing that we had to do, after monitoring entities made themselves known to DWR, after they've developed monitoring plans, we had to prioritize those basins. And I'll go into the details as far as what goes into that prioritization in a few minutes. But with all the things that we had to consider, looking at those 515 basins, we determined that there were 127 high and medium priority basins that account for about 96% of the average groundwater extraction in those areas, and accounted for 88% of the population, at least the 2010 population that overlied those areas. So you can kind of see it broken down by here: 43 high, 84 medium, 27 low, and then 361 very low priority basins. But I do want to point out that just because a basin was prioritized by CASGEM as a very low priority basin, it doesn't mean that that particular basin isn't 100% reliant upon groundwater. It may not have any surface water supplies available. But it's the high and medium priority basins, those 127 basins that are identified here in orange and yellow, that are required to address the Sustainable Groundwater Management Act requirements. And we can go into that again in a little bit more detail later. So now I'll roll through the three hydrologic regions in a little more up-close version of these figures. But I want to point you to the bulleted items on the left-hand side of the screen. And if you're really interested, go to Water Code section 109.33b. The Water Code directed the department to consider all 8 of these bullets when it prioritized the groundwater basins. It had to do with population, number of public supply wells, total number of wells, irrigated acreage, and so on. We did a draft prioritization in, I believe it was June of 2013, and we did December of 2013, and we did this final prioritization in June of 2014, and ultimately it was that final prioritization that we did in 2014 that was taken as the initial prioritization with respect to SGMA in those basins that needed to comply with the Sustainable Groundwater Management Act. What I want you to see or focus on is the text in the last bullet that's in yellow. Adverse impacts on local habitat and stream flows, and that relates to surface water groundwater action as it relates to groundwater use in particular basins. SGMA added those 2 particular components to the prioritization requirements. So those of you that have been following SGMA, those of you that have seen our basin prioritization listing sessions or have been part of one-on-one discussions with DWR, it's a component of SGMA to provide regulations to let local agencies request that their basins be modified. Those regulations are due the first of the year in 2016. We'll look at those requests, we'll analyze those requests, and ultimately by the end of 2016, early 2017, there'll be some new groundwater basins identified. And once those new groundwater basins are identified, we'll have to use all of these components to then reprioritize the California's groundwater basins. My guess is the number will change from 515. Hopefully it won't go up. Most likely will go down. But more on that in the months to come. So this is just a close-up of the Tulare Lake region. 7 high priority basins, 1 medium priority basin, and you can see these basins definitely cover most of the groundwater use and most of the population that overlies these basins. The San Joaquin River, 7 high priority basins, 2 medium priority basins, and all of the groundwater use from these particular basins, and most of the, well, according to this, all the population that overlies those basins. And again, far more details are in the specific region reports. Then finally, the Central Coast. You know, smaller basins, generally speaking, but 9 high priority basins, 15 medium priority basins. It captures most of the groundwater use, 97%, and 90% of the population. Now on to water quality, and a sip of water. The DWR partnered with Central Valley, well, not the Central Valley, all the regional water quality control boards to write up groundwater quality information that they had available. The state board and the regional boards definitely are the keepers of the quality information. So they wrote up information. We took that information and then incorporated into the water plan. But in each of the hydrologic region chapters, there's really good tables of data sources where you can go to get various types of information. There's information about community drinking water wells, details about the Gamma Priority Basin Project, you know, the regional board or the Gamma program information about domestic wells, groundwater quality protection strategies, and there's also the information that's available through the department's water data library. You know, these are just a chart and a table that I took out of a 2013 report by the state board about communities that rely on a contaminated source for drinking water. So each of the hydrologic region chapters have some really good places to start with respect to finding out quality information. And now let me catch up with my notes. We're kind of on to some supply data. There's a lot of things going on here, and I'll highlight a few things. This is a statewide perspective. The taller light blue bar reflects the total water use in thousands of acre feet in a particular hydrologic region. The shorter blue bar indicates the amount of that total supply that comes from groundwater. So let's use Tulare Lake as an example right here. You know, based on this information, and again, this uses average information from 2005 to 2010, indicates that in the Tulare Lake hydrologic region, on average, 11,636,000 acre feet, which is the same as 11.636 million acre feet, was used, and 53% of that total supply came from groundwater. You know, you could see based on these bars, the height of the bars, Tulare Lake region, you know, uses the most amount of groundwater, and so on and so on. To draw your attention down to the graph or the table right here, again, it breaks it down by, you know, total amount of groundwater used. I guess I kind of skipped this. Using the average information, 43 million acre feet was the total water supply in California during this period, and again, on average, 38% of that total came from groundwater. And of that 38%, you know, this three-dimensional pie chart breaks out, you know, which hydrologic region used what of that 16.461 thousand acre feet. Tulare Lake used about 38% of that amount. The San Joaquin River used 19% of that amount, and the Central Coast used 7% of that amount. And how to read these tables down here. So this is the total water use met by groundwater. You know, it's the total average groundwater use. And starting from left to right, it's the agriculture use met by groundwater. And I'll just look at the bottom number. Of the total water use met by groundwater, you know, what's that? Probably 75, 80% was used by agriculture, but groundwater only met, here it is, 39% of the total agricultural use of water. Again, urban needs over here, groundwater only met 41% of the urban needs of the total water supply. And then there was, or is, a small amount of groundwater that's used for managed wetlands. Now we'll break it out by hydrologic region, again starting with Tulare Lake. I went over these numbers as an example. Again, these are average numbers and really approximations. These aren't numbers reported to us based on recorded water use. It's just estimates based on land use surveys, based on evapotranspiration rates. The list goes on. These are estimated amounts. The real numbers could be far higher or even lower. But with respect to the Tulare Lake region, like I said, 50% of their total supply comes from groundwater. And here's kind of a breakdown of the 8 planning areas for that particular hydrologic region. And a planning area is a California Water Code division of a hydrologic region. It's how we group information. But you can see here kind of which planning area used the most amounts of groundwater in the Tulare Lake region. What's the highest is the Kauai Delta, and then very little up here in planning area 701, the western uplands. But yet definitely the Tulare Lake area is the largest user of groundwater. Onto the San Joaquin River hydrologic region, 7 different planning areas using less groundwater, and they've got a less reliance upon groundwater. 38% of their total supply comes from groundwater. Then you can see here how it's broken out by planning area, which area uses more groundwater than another. Far more details and better charts and better, well, I think this is the figure, but better tables that kind of break out all that information in the printed reports. Here in the Central Coast, using a lot less groundwater, well, their total water supply is a lot less with respect to the Central Valley hydrologic regions, but they use 86% of that total supply comes from groundwater, and so by far the Central Coast is most reliant upon groundwater. Then again, you can see here with the bar charts and the 3-dimensional pie chart, kind of what areas are using what percentages of groundwater. I think this is where it gets a little bit busy. I'll do my best to describe this. It's even still confusing when you read about it. But what this does is take the information from the previous slides, and we call these butterfly charts for a pretty obvious reason. This particular one looks at total water supply, and it's a volumetric approach on the right-hand side, and it breaks it down by groundwater, surface water, and reuse or recycled water. And the information in the center column is the water year, and the percentage in parentheses is the percent precipitation based on a 30-year running average of normal. You can see, a relatively normal year in 2010, maybe some wetter years in 2006 and 2005. So it takes this volumetric approach on the left-hand side and turns it into a percentage approach on the left-hand side. It kind of does a trend analysis of year to year, wet years, dry years, which source is used predominantly. But from the 2002 to 2010, there was a high of over 45 million acre feet when precipitation was low, to a low of almost 40 million acre feet when precipitation was high. And again, from the previous information, the average total water supply was 43 million acre feet. This then takes that total water supply and translates it into groundwater supply. And this helps a little bit. So what it does is take this blue bar up here, the groundwater component of the total water used, and then translates it down here into a different projection, and then it breaks it down into, of that groundwater, how much is used by agricultural purposes, how much is used for urban needs, and then what's applied for managed wetlands. And again, takes this, and this is only groundwater down here, takes it to a percentage perspective on the right-hand side. So you can see again, when precipitation was low, there was more groundwater used, in this case 2009, and it met 46% of the total supply. Or when precipitation was high, there was a less need for groundwater. It was a low of 12 million acre feet. And again, from the previous slides, the 5-year average was about 16.5 million acre feet. So hopefully that's clear, kind of highlighted in circles, kind of the highs and the lows. And now we'll look at this slide, which kind of throws all three hydrologic regions together. Kind of made a point of indicating where the information is. The water year and precipitation, blue's groundwater, green surface water, yellow's reuse water. But one thing I want to make clear is this horizontal scale is different. If it were the same, it wouldn't look as nice and even like this. But starting in the Tulare Lake region, again, there's the groundwater component, surface water component. Kind of indicates volumetrically what's used during which year. Again, down here, some of the wetter years, far less groundwater. Translate that information over to a percentage. And in the wet years, a lower percentage of the total water supply comes from groundwater, because there's surface water available. And this is variable. More groundwater or more surface water available, less groundwater use. A little more stable down here in the San Joaquin River hydrologic region. Again, broken down by groundwater, surface water, and reuse water. This kind of assumes maybe there might be a little more stable supply of surface water, because depending on the amount of precipitation, it doesn't fluctuate as much as the Tulare Lake hydrologic region. And then when you translate that information over to the left-hand side, a little more stable percentage-wise. Generally speaking, give or take a few percentage points, around 40% of the total water supply comes from groundwater. But again, you can see down here with the Central Coast, far less surface water supplies. So on a year-to-year basis, despite the percentage of precipitation, well over 80, if not 90% of their total water supply comes from groundwater. And again, just want to make sure that you all know the charts don't use the same horizontal scale. So then this takes that same information, like I discussed from a statewide perspective, and translates it to groundwater only. And I won't go into a lot of details in the interest of time, but again, the light brown, if you can see it or differentiate between the pink, the biggest bar is agriculture, the smaller bar in the pink is urban, and then if there is one, and it's generally pretty small, it's managed wetlands use. But you can see in the Tulare Lake, with respect to only groundwater use, most of the supply, most of the groundwater that's used goes towards agriculture. And again, on a year-to-year basis, well over 80, if not 90+% of that groundwater goes towards ag. The San Joaquin River hydrologic region, again, pretty stable percentages with respect from year to year, water year versus the amount of precipitation. Give or takes, there's 70 to 80+% of the water is used for agricultural purposes. And then down here in the Central Coast, once again, most of the groundwater used is for agricultural purposes, 80%-ish, give or take, with the rest going to supply urban needs. And there's a lot more details, a lot more assumptions that go into this analysis, and I'm just highlighting the key things for the presentation. So now I'm going to actually grab a few notes for this particular presentation. Groundwater contours. Let me kind of catch up with myself. This was done only for the Central Valley. The presentation of depth to groundwater information and groundwater elevation information. It's a simplistic view of looking at it from this point of view. And the reason why it was only used for the Central Valley is because, as I showed on some of the previous slides, the density of groundwater elevation monitoring wells from a publicly available perspective was much greater in the Central Valley than outside the Central Valley. So what this does is look at depth to groundwater, and that's a measurement of, in a well, from when you are at the top of a casing down to when you first encounter water within the well. It's a depth from the top of casing. As you can see, the the depth to groundwater in this, and I'll talk about the Sac River here because it's Central Valley specific. Depth to groundwater in the Sacramento River hydrologic region, generally range between 10 to 50 feet below ground surface. I'm going to pull up some notes real quick. It kind of shows it's extremely variable, from north to south. Like I said, 10 to 50 feet in the Sac River. In the San Joaquin Valley groundwater basin, depth to groundwater in the western half is really shallowest along the valley floor adjacent to the Sac River, or the San Joaquin River and its tributaries. But on the eastern side of the valley, it could be due to widespread agricultural development, insufficient water supplies. It results in significant declines in the groundwater table. And there's regional depressions that exceed, 250 feet below the ground surface. In the Tulare Lake hydrologic region, depth to groundwater in the northeastern 1/3 of the region, the Kings and Cahuilla subbasins is shallowest. Okay. Along the valley floor, adjacent to the Sierra Nevada Valley foothills, but then moving west, as groundwater extraction for urban and ag uses increases, the depth to groundwater contours become increasingly, irregular and variable. So the depth to groundwater information is then translated over to groundwater elevations, and groundwater flows from areas of high elevation to low elevation. And that's generally depicted by these white lines. It shows just a general approximation and a very simplistic view of the direction of groundwater flow. Up in the northern part of the valley, kind of flows, from the Sierras or the coastal areas towards the axis of the valley where the Sacramento River is, and then flows south into the delta. The Tulare Basin down here is a closed basin, so it kind of flows within the basin, but in the San Joaquin hydrologic region, once again, it kind of flows from the Sierra Nevada or the coastal areas towards the San Joaquin River north into the delta. This talks again elevation and kind of the scale on the up here. The elevation goes from about 600 feet above sea level to over 50 feet below sea level. In some of these areas, kind of in the Sacramento River hydrologic region, and this part of the San Joaquin hydrologic region, you can see other areas throughout the San Joaquin Valley. This orange shows where groundwater elevations are well below sea level. And in these particular cases, or in cases where it would be in coastal basins, that causes seawater intrusion, from oceans, or could cause upwelling of higher salinity water, from deeper water, that was trapped in old marine sediments. So again, much more details in the standalone reports. Now we'll go into this approach, and this looks at changes in groundwater elevations, and I'll present this information a little bit differently, and a lot of this information is available on a planning tool I'll give you the web address for in a few minutes, but it takes real water elevations measured from monitoring wells throughout the Central Valley and compares them from one time period to another. In this particular case, it's spring 2005 to spring 2010. This scale over here, if you can see some areas that are purple, the elevations have actually gone up. My guess would be if you see those areas on this particular map, they're in locations of conjunctive management areas where they're doing groundwater recharge. You can see a lot of these areas are dark red, and that shows a substantial loss or a loss of groundwater elevation over this time. Again, this slide, and I've been told I have about 10 minutes. I tend to talk about certain things, but I'll talk this on a general scale. I highly suggest you go in and read this information on the reports, because this talks and change in groundwater in storage. This is a cumulative graph that adds together the Sac River, the San Joaquin River, and the Tulare Lake hydrologic region. Again, it's based on real information from real wells, but again, this is representative primarily of the shallower unconfined systems throughout the valley. The table here This was a particularly wet year, and it's identified by the color ramping on these particular charts. Wet year, critical year, below normal years. This was a wet year. There was an average increase in groundwater elevations, which resulted in increased storage. But you go down the table from the collective and cumulative approach from 2005 to 2010, on average, there was almost a 10-foot lowering of groundwater elevations, which represented a total groundwater storage decline of, upwards of 5.5 million acre feet to over 13 million acre feet a year. And then this information in green, we're talking about a sustainability perspective. That's an overdraft of groundwater on a collective basis of over 1 million acre feet per year to, well over 2.5 million acre feet per year. Again, far more details in the reports, but to kind of hammer that particular piece of information home, when you break it down by hydrologic region, anywhere from 1 to almost 2 million acre feet has been taken out of the Sac River hydrologic region, 1 to almost 3 million acre feet out of the San Joaquin River hydrologic region, and somewhere between 3.6 to 8 over 9 or almost 9 million acre feet per year. What I didn't get into, and I'll just say briefly, these are assumptions, and these are based on very simplistic views of calculating change in groundwater storage. The process that we used to do this was vetted through our Groundwater Caucus, and the particular storage coefficient applied to this was specific yield, and it used a range of specific yield numbers that range from 0.07 to 0.17, and those were generally considered some acceptable values that were contained in two models that represent the Central Valley. I'll go over this quickly. Here's a website where you can get more up-to-date information. Right now, I think it's active through 2014, but the information from spring of 2015 is currently being vetted. And you can zoom in on this, focus in on your area, and determine what sort of information is available. Also, the updated drought information. There's some locations. Here's the website where you can look at up-to-date information through 2014. And I do want to point out that the information that is contained in these drought reports really was based on some of the efforts and analysis that were built for the water plan effort. And so it was those maps, it was those tools, it was that data collection system that we started with the water plan that really helped facilitate some of the presentation of water information specific to the drought. I'm going to skip over this, but it's telestory hydrographs. This is a figure from the statewide report. It talks about themes, and those themes are specific to groundwater demand, recharge potential, how certain management actions, or how the aquifers responded to certain management actions. Each hydrologic region has telestory hydrographs, and this is just a compilation of some of the hydrographs. You can see hydrographs, which is a measurement of groundwater elevations at a specific time. If those hydrographs are going up, if those hydrographs are going down, if they've stabilized, why did they do that? In the interest of time, I'll skip over some of the details, but it's an interesting read. There's lots of information in the individual hydrologic region reports. Tell them to view the first presentation on the website. If you want a statewide perspective, the statewide webinars that Abdul Khan did are on the website, and he gives a good overview of that as well. So here's some of the examples we use for the San Joaquin River, and here's some information that is specific to the Central Coast. Land subsidence is an important component of groundwater management. Again, without going into a lot of detail, there was a lot of land subsidence seen in the Central Valley, primarily the San Joaquin Valley. Between 1926, there's in some areas 24 feet of land subsidence occurred. The Central Valley Project, the State Water Project, brought in surface water to those areas with the intent of arresting it or stopping it. Well, recently we've seen land subsidence rates that are greater than what we're seeing in the past. In some areas, rates as high as 1 foot a year. And Appendix F in the report is going to have some really good references to a recent study that was done by Ludorf and Scalmanini, sponsored by the Water Foundation, specific to subsidence related to groundwater withdrawal. On that interactive website that I said go look at for up-to-date groundwater level information, There's also this interactive site that looks at land subsidence information and what information may be available in your particular area. And again, go to that website and it'll take you there. I'm going to have to probably go through this quickly, but this is groundwater management legislation. The next couple slides I'll show kind of the availability of groundwater management plans throughout the state. Groundwater management, is discussed in part 2.74 of the Water Code. It started in 1992 with AB 3030. Updates were done with SB 1938. CASGEM was in 2009. AB 359 came in at 2011. That didn't go into effect until 2013. Then obviously most recently was the Sustainable Groundwater Management Act, which was in September of 2014. I do want to highlight AB 359. It wasn't until this piece of legislation where it was an absolute requirement that local agencies that develop groundwater management plans were required to provide to the department those plans. So what we did as part of the water plan effort was, on a region office scale, we went out and tried to get a hold of all the groundwater management plans that were out there. Lots of phone calls, lots of outreach to local agencies. So this is a statewide map of where those groundwater management plans are. The lighter green are SB 1938 compliant plans, or those that have been prepared after 2002. The darker green are those plans that were prepared prior to 1938 that we call AB 3030 plans. About 119 plans that there were a few more that kind of straggled in after the fact, and there's definitely more that have been approved since then. But of those 119 plans, 82 were developed in accordance with SB 1938. We did an assessment of all the things that are either required or recommended or suggested components of the plans, and determined that only 35 of those 82 plans contained all the requirements, which really only covered about 17% of all the groundwater basins in California. More details online, but this kind of gives a pie chart of the required components, basin management objectives, agency cooperation, maps, monitoring protocols, kind of what plans met what component. We break it out by hydrologic region, and the one thing I'll say as I flip through these next couple slides is lots of areas are covered by existing plans. I highly suggest for those folks moving forwards with SGMA and the development of groundwater sustainability plans, and this is a good place to start. It's a good place to figure out what's been prepared in the past, looking at management actions, looking at objectives, looking at goals in those plans. They're all available for downloading on our Groundwater Information Center website. And again, these are just some statistics specific to each hydrologic region, that I'll go over in the interest of time. Again, good coverage within the San Joaquin River hydrologic region. A lot of them prepared in accordance with SB 1938. For the groundwater basins in the Central Coast hydrologic region, again, 9 plans, 4 of those meet the SB 1938 requirements. 2 of them have all the requirements in those plans. I do want to say that the assessment we didn't look at it from are these plans good, or are these plans actively or successfully managing groundwater. It was just a comparison of what was required to be in those plans and if they even addressed it at all. So each one is different. Each one addresses groundwater management different. So again, read the plans, look at the specific regional reports, and you'll get a better understanding of what's in those. More efforts related to groundwater management. This is a map showing what areas in California have groundwater basin adjudications, but there's also a brief discussion in each report about special act districts, groundwater ordinances, and other management efforts, such as integrated regional water management plans. We attempted to do an inventory of California's conjunctive management programs, and let's just say it's a really good place to start. We asked for information from local agencies about the location of the project, when it was developed, the capacity of the project, where was their source water, how do they get into the ground. We identified 89 programs throughout California. These red dots don't necessarily reflect the locations of the active recharge, but the locations of the agencies that are managing those programs. There will be in Appendix D the results of that survey, the responses that we did get when we did the outreach to those agencies. Briefly speaking, of the 89 agencies, 31 gave us responses about when they were installed. Coincidentally, it was with the enactment of the AB 3030 legislation and Prop 13 funding through DWR. Of the agencies that gave us responses, lots of them used water from the State Water Project, lots used surface water supplies, and then, Central Valley Project, recycled water, and Colorado River supplies as well. The most common method of recharge was direct percolation. Lots used in-lieu recharge, but many of these agencies used multiple methods to get water into the ground. And then again, overwhelmingly, other than being part of the conjunctive management program, overdraft correction was the reason why these local agencies were doing conjunctive management. Dan's going to go over this in a bit, but these were the 9 recommendations that we included in the water plan, the statewide chapter, but I highlighted the key components I want you to look at. So many of these recommendations had to do with public education, collaboration, access to groundwater information, improving essential data, conducting basin assessments, advancing sustainable groundwater management, improving analytical tools, and increasing groundwater recharge and storage. The statewide chapter as well as the hydrologic region chapters have bulleted findings specific to these particular groupings, identifies data gaps, and makes recommendations that are similar to the statewide recommendations but appropriate to the hydrologic region. All the information, hopefully you've seen this already, is available online. Here's the website. Sign up for the Water Plan e-News if you're not already signed up for it. I'm part of the department's groundwater sustainability or sustainable groundwater management program. We have a new website. It covers our SGM program, lots of technical information under the GIC. It has links to the CASGEM program and Bulletin 118, how it exists now, but also as it's going to be updated, information will be put there. If you're interested in the intricacies of the legislation, here's a website to go to that talks about legislation. And my role is done. The first hydrologic region webinar we're almost finished with, and then the next couple will be on July 27th and August 26th. Thank you.
Thank you. We're going to turn this back over to Dan. There were 2 somewhat specific questions that I'm going to ask you. I know we have a Q&A in just a minute, but if we can address them because they're particular to the piece here. And Dan, I'm turning this over to you so you can go ahead and open up your slides. The first one was how much of the data is empirical and how much is actually coming from well logs or on well meters?
I don't believe, if you're talking about groundwater supply, groundwater use, groundwater extraction information, those are all estimates. Again, I can find the section in the reports that talk about how that data is assumed, but again, it's based on land use surveys, it's based on land uses, it's based on a variety of numbers that result in simply estimates of groundwater use.
And I would just add to that, Mark, that for the urban data, we do have on the community service wells, and urban wells that serve more than a certain number of people, we do get reporting of their use. So that data is a little better probably than the land use data, but the land use data also seems to match fairly closely with what we're seeing in the field.
Good.
Great.
The other question that came in, which I'll quickly answer, it's about the spring 2010 groundwater contour maps, whether or not the maps represent the water table or some composite of the aquifers. Our goal was to query, of all the wells that are in our system, query those wells that are representative of the water table. I don't remember exactly, but it's the upper, the water table. It doesn't necessarily reflect those deeper confined aquifers, and the way we were able to query that is based on known depth to water measurements, known depth of wells, known screen intervals. But that's not to say that because of the quality of the information that comes into the department, some of that isn't a little bit erroneous because it may be a composite of, you know, semi-confined system, or, you know, quite simply on lots of these, the well logs are wrong. So what we think is there may not actually be a true representation of, you know, what the well is actually showing. So again, it's a simplistic view. It's a process that we have. It can definitely be improved upon with the improvement of data.
Mm-hmm. We do have additional questions that have been coming in. They're a little bit more macro, so I'll go ahead and take those up on the Q&A, but those are more specific about your slides. So with that, let's go ahead and turn this back over to you, Dan. And then if you're in the audience and you do have questions, if we're not able to get to all your questions, we are compiling questions. We are going to be putting those. We've been doing notes from the sessions that get posted with the meeting materials. And so you can go over there and look, and we'll try to get questions answered even if we can't get to them. And in a couple of cases, I've actually been communicating with a couple folks online, and we'll send you an email specifically because you've asked a rather specific question. So with that, go ahead and take it away, Dan.
Okay, can you see my screen okay?
We can.
Okay, great. Well, obviously a lot's happened since we started working on the 2013 groundwater update associated with the California Water Plan. We wanted to provide a kind of a quick overview of some of the recent changes with respect to groundwater management in California and some of the activities the department's going to be doing. And we have the, obviously the California Water Action Plan was developed in January 2014. We have the Sustainable Groundwater Management Act, which consisted of 3 bills that were enacted in September of that same year. And then our program, which was developed early on this year to respond to the Sustainable Groundwater Management Act. As far as the California Water Action Plan, it represents a fairly extensive collaboration between a large number of state agencies and local interests, and the characterize California's management goals, their actions and challenges over the next 5 years, and helps guide efforts to enhance water quality, water supply reliability, and restore ecosystems and improve the resiliency of our water infrastructure. It includes 10 main actions, and one of those actions, action number 6, speaks directly to groundwater by highlighting the need for additional storage and improved groundwater management. So this slide just wanted to, is a quote by Governor Brown, which really just underlies the overall intent of SGMA, and that is that groundwater is best managed locally, and I think the legislation did a pretty good job of attempting to craft that into it. The other thing we want to talk about, Mark showed the recommendations from our report, but if you look at the recommendations compared with the California Water Action Plan and the SGMA legislation, I've highlighted in yellow here about 5 of the 9 recommendations that we provided in our report have been included in both the Water Action Plan and SGMA. So it indicates a fairly good nexus and alignment between these 2 documents, or 3 documents. SGMA overview. Our department, we try to break it into 3 main areas, and that's first the framework, which really provides the kind of the background and the information needed to develop the plan. It talks about has the definitions and who needs to do a sustainable groundwater management plan. Then it also has a list of local roles for establishing groundwater sustainability agencies. It lets them know which additional authorities and powers they have, highlights the need to develop groundwater sustainability plans, and then has some dates and deadlines in there. Then it also captures a state role, which talks about basin boundaries and priorities, our role with technical assistance, and evaluation assessment of the basins. And then finally, in those basins where the locals aren't able to manage sustainably, it talks about the state intervention for groundwater management. So this is just a timeline that's available online. I know it's hard to read with the webinar, so we're not going to go through a whole lot of detail, but there are, it's a pretty useful timeline. It's kind of a joint product between the Water Board and our department, but it highlights the different actions that are required of the different agencies and locals. And the Water Board actions are highlighted in this blue color. The DWR actions are in orange, and then we have these joint actions between the Water Board and DWR, and then the green are the local actions that are necessary. And up front, you can see it, or maybe you can't see. It's the actions are pretty heavily geared towards department doing a number of things. And this one here is we have to release our new initial basin prioritization. We have to identify conditions of critical overdraft. We have to adopt regulations to revise basin boundaries. And we also have to adopt regulations to evaluate groundwater sustainability plans, and then publish a report highlighting the water available for groundwater replenishment. So we're pretty busy over the next few years. As far as the definitions go, it also provides a definition for sustainable groundwater management, and it's the management and use of groundwater in a manner that can be maintained during the planning and implementation horizon without causing undesirable results. And then also provides a definition of undesirable results, and those are conditions indicating significant, an unreasonable, lowering of groundwater levels, reduction in storage, seawater intrusion, water quality degradation, land subsidence, and depletion of surface water. So with that, the department developed a program around SGMA, and we developed our strategic plan that came out earlier this year, and we're still taking comments on that plan. It's kind of some folks feel like it's a little high-level document, doesn't get into the weeds enough. Others we've heard comment that it's a little too specific for where we are. We know it doesn't address everything, but that's actually by design, because a lot of things are still being determined as we go through the process of developing regulations. But some of the things we do try to capture, and we put these in terms of 5 main objectives. And these objectives are really centered around the legislation. So each of these objectives relates to a specific piece of legislation or requirements for locals or the department. And then each of these also consists of a number of sub-actions or tasks that need to be done in relation to that larger objective. And just to put in perspective, the first one here, developing a framework for sustainable groundwater management. This gets to the department providing some of the baseline data, publishing our best management practices, updating the basin prioritization, evaluating basin subject to conditions of critical overdraft, that type of thing. For technical assistance, this really relates back to some of the monitoring programs our department has, and for groundwater level, groundwater quality, and data. And then also, it talks about our department's need to develop really a groundwater management information center where people can provide and report their data for their sustainability areas. And then as far as planning and assistance, this is really where we're going to provide our Bullet 118 updates, and then explain how those updates will be integrated into future Bullet 160 plans. As far as assist and alignment for here, it's really all about providing financial assistance and facilitation services, and going out and doing our education and outreach. And the interregional assistance relates back to the IRWM programs, and really just the need to integrate the groundwater sustainability efforts with those programs, and then also to look at the need for additional storage and conveyance projects. Our communication outreach program is fairly robust. It goes beyond what's required by the legislation to implement regulations. As you can see, it has a approach that allows us to provide a focused approach with one-on-one meetings, but also yet still look at a broad range of interest by having public meetings and advisory panels. So we're really taking the communication outreach seriously, and the idea isn't really to necessarily develop consensus on all the issues moving forward, but really to try to develop a shared understanding so we can develop the regulations and tools that we need in a practical way that will help support and implement sustainable groundwater management. So I showed you the timeline. These are the 4 immediate actions that we really need to develop and get out over the next couple of years. Develop regulations for basin boundary revisions. We need to update our basin prioritization to add that component to number 8 that Mark mentioned, which is including groundwater impacts to stream flow and habitat. And then we need to identify basin subject critical conditions of overdraft, and we need to develop regulations for groundwater sustainability plans. So some of the overall process and the phases of implementation, we've outlined four different steps here, and the first one is really scoping and notifying the Office of Administrative Law of our intent to develop these regulations, collecting issues from stakeholders through some of those 101 and public listening sessions, coordinating what we're doing with the State Board and the Water Commission, and then going back and drafting that framework, and then going back out and providing opportunity for the public to really provide input. Once we've done that, we'll go back and actually draft the final emergency regulations and provide those to the California Water Commission for approval, and then noticing and submittal to Office of Administrative Law. That's a pretty detailed graphic here, but it shows a timeline for developing our basin boundary regulations and our groundwater sustainability plan regulations. The top part relates to the basin boundary regulations, and the bottom part here is for the sustainability plans. And there's a number of dates and deadlines here, but the thing I want to highlight is really just when the public can offer input and opportunities for them to step in and provide comments. We've already had a number of our listening sessions for the basin boundary changes. We're going in and we're developing our draft regulations right now, and then come September and October, after those have been out for a while, we're going to be having public meetings and getting additional feedback and comments on those draft regulations. We'll make our edits and go back to the Water Commission on those, and then finally in December this year we'll be submitting those to Office of Administrative Law. Down below is our groundwater sustainability plan process. We'll be doing our listening sessions based on kind of some key topics, discussions we're going to break out, and those will be a much longer period from July through probably October, and I'll explain why in a minute. And then we'll go back, similar to the basin boundary regulations, and draft our regulations based on the comments and information we received, and follow through the same process until we submit those regulations. Once again, as far as public input, the January, February public meetings is a good opportunity to provide comments, as well as the listening sessions that will be carried out over a number of months between July and October. When I talked about the groundwater sustainability plan regulations, I mentioned the listening sessions are extended over like a 2 to 3 month period, and that's because when we started looking at the requirements for the sustainability plans, there are a number of topic areas that need to be covered. So what we're going to do is we're going to break those into 3 main areas that have about 3 to 4 topics each, and each of our listening sessions will then be based on these topics. So as mentioned, the first batch, this red batch, will be sometime in June, July. The second batch, July to August. And the third batch, if we're still on track, will be August and September. And so with that, I just want to encourage you, Mark made several references to the online and the versions of the plan. Please go there and take a look at those, as well as our groundwater sustainability program. And if you have any questions, these are the emails you should provide and the contact information for that. That's about all I got.
Great, thanks so much, Dan. Well, people have been sending in questions, so I'll go ahead and jump in and get a few of them covered here. So first of all, you have a lot of information that goes all the way up to 2010, but what do you have for after that? Do you have well drilling info or any other kinds of things since 2010?
Well, we have been providing, periodic updates of well drilling activities for the drought efforts, and then I think one of his slides also included a couple of reports that we've developed in response to the drought. And in those reports, we try to kind of catch up and summarize some of the more recent data. So there are those efforts, and then also some of the more recent information we're shooting directly to the Groundwater Information Center, kind of our online tool for folks to get data. And I would encourage folks to go there if they want to look at groundwater level data and contours or change maps.
Yeah, just to echo what Dan said, the slide that we'll have available online pretty soon in a PDF form gives links to those drought reports. And again, it does a good analysis of 2010 through 2014 groundwater levels specifically. And if you those nice colorful maps that showed changes in groundwater elevations from 2005 to 2010, we've had 4 years of historic drought where there's been surface water curtailments, and in those areas that already have very deep depth to water groundwater sources, they've gotten even deeper from 2010 to 2014. So those are good sources of information to look at what's been done recently, as well as the tool Dan just mentioned.
Great, thank you. Now, you showed quite a few pictures with the Salinas Valley and the Central California, and there are other kinds of well data, though, right? The water boards has something that they do. So could you just briefly mention about that data, and are you using it?
Yeah. So the information that we used is information that we have through CASGEM or our cooperators or USGS or US Bureau of Reclamation. So that's publicly available data. There's lots of areas where there was no data available on the maps. Like I said, that doesn't necessarily mean there's no data being collected. This question specifically talked about GeoTracker, and that's a site that's done by the State Board, State Water Resources Control Board, and the regional boards. And in GeoTracker, I apologize if I kind of describe this, but the GeoTracker site is primarily for, there's lots of data on it. It's primarily for contamination sites. And generally speaking, those contamination sites have monitoring wells that are pretty shallow, and those shallow wells are not necessarily representative of all the drinking water sources that we're primarily interested in.
Okay.
I don't know if Dan has any.
And I would mention that the GeoTracker site does have groundwater level information also, but that information is downloaded about once a year from our water data library and our CASGEM site. So it's somewhat of a mirrored site of our groundwater level data. And as far as well completion reports, those are reported to the department. So the well installation data comes from our database from our different regional offices on a number of well logs that have been submitted there.
Okay, great, thank you. Now, you've been talking a lot about how much water is coming out by year and so on and so forth, but how much is left?
That's a good question, and it's something that probably needs to be looked at more closely in the upcoming years. And typically we kind of caution or stay away from trying to describe the full basin capacity, because clearly long before you reach those lower limits in the basin, you probably dewatered most of your wells in the basin and have water quality issues. But one of the things we recently did is we updated the Basin freshwater map for the Sacramento Valley, and we're working on that same map through our South Central office for the San Joaquin Valley. And once we get the Basin freshwater updated and characterized, that will provide a pretty good estimate of what that those final drops are and where they'd be coming from.
Yeah, and I'll add to that a lot of the information that we have and the information that we've posted, there's lots of aquifers within the Central Valley. Upper water table aquifers that are unconfined aquifers, deeper semi-confined aquifers, or much deeper confined aquifers. Some wells are installed to monitor those specific aquifers. Some production wells are screened for several hundred feet just to get as much water into those wells as possible, and they're pulling from an unconfined system as well as a confined system. Like Dan said, the Basin freshwater maps will be extremely useful, because it doesn't necessarily mean that there's no water left, but it's the quality of that water and whether or not it's even usable that's a concern.
Mm-hmm. And that's a little bit related to another question that we got, which had to do with as you are taking water out, what are you looking at in terms of permanent loss of storage capacity due to the collapse of the aquifer and some of the other subsidence things that are happening?
Yeah, so that is an issue, and you know, it happens mostly in the fine grained portions of the aquifer or the clay, the really fine grained portions of the aquifer. And in some areas that'll show up in the hydrograph response actually, instead of, you know, the hydrograph drawing down, you know, 10 feet, say, for a particular amount of withdrawal, you might see that hydrograph draw down an additional amount for the same amount of withdrawal. I don't know that we've gotten to the point where we've calculated, you know, the total loss of storage that's happened and is still ongoing, but that's another one that we need to work on.
Okay. Now, you've been talking a lot about what the state has been doing and what government has been doing. Is there a role for the private sector to be doing this? Is there a way to assist or provide, you know, do like listening sessions or provide guidance and comments? And what about the nonprofit sector?
Well, yeah, and chime in, Mark, if you want, but I think there's a huge role for them to play as far as just staying up to date with what's happening in their area as far as the implementation of the Sustainable Groundwater Management Act is concerned, and also with what's going on with their broader integrated regional water management planning. You know, we will have the listening sessions as we go through these two kind of important regulations to look at changing basin boundaries and to look at how we'll evaluate groundwater sustainability plans, and we certainly would welcome public input and you know, nonprofit folks' input on that. And then locally, I think, you know, a lot of these plans need to coordinate with the cities and counties because there's a general plan coordination component to SGMA, and so I think, you know, attending, you know, the Board of Supervisors meetings when they talk about, you know, developing their GSPs or their groundwater sustainability agencies and what's going to go into those plans. I think that'll be also an important avenue for just the general public to participate in this effort locally.
Yeah, and I'll add to that education. You know, this is groundwater. You know, you can't see an aquifer depleting, but you can see reservoir levels lowering. So, you know, if there's any opportunity, you know, for consultants or nonprofits, it's education about groundwater, because there are so many areas that are now going to be required to develop groundwater sustainability plans where prior to the enactment of SGMA, they were not required. Yeah, I'll add, maybe I had to rush through it. I maybe had intended to talk about it. But all the legislation that occurred prior to SGMA, AB 3030, SB 1938, generally speaking, it was a voluntary approach, you know, often done by proactive agencies that wanted to better manage groundwater. But generally speaking, there was no teeth associated with most of those plans. There is now. With SGMA, it's those high and medium priority basins, those 127 high and medium priority basins that have to comply with SGMA. You know, groundwater sustainability agencies, which is going to be an extreme challenge as it provides those GSAs. It's a new governance structure for managing groundwater. And I highly suggest folks go onto our website or the groundwater website, download the text of SGMA and read it front to back, because it's complex, and if you don't understand it now, you'll understand it's going to be extremely challenging. But those GSAs are required to be formed in high and medium priority basins by June of 2017. If governance is not structured by July 1st of 2017, there's an opportunity for the State Water Resources Control Board, per the requirements of SGMA, to come in and act as a state intervention, a state backstop authority. So I highly suggest local agencies not rush into this, coordinate, you know, not only with other local agencies within their basin, but counties within their basins. You know, there's a list of beneficial users of groundwater that I highly suggest folks start to coordinate with, because this is going to be a pretty heavy lift, and, you know, in my opinion, you're not going to want to go it alone. And once again, it's the data, the education. You know, a lot of these agencies, these local agencies that are going to be required to comply with SGMA, may not have in-house staff that can do what's going to be now required of them. You know, if there's any opportunity, once again, for training and workshops, you know, that's the way I see these additional efforts assisting.
Mm-hmm. So speaking of what you just talking about.
Quick add-on, Lisa, on our sustainability site, we do have to list the people that have applied to become a GSA or Groundwater Sustainability Agency. So if locals are interested in finding out who in their area may have applied, I would suggest they go to that site and look at those applications.
Perfect, thank you. Speaking of being able to do education, you've provided a lot of really wonderful, powerful communication tools and images. Is it possible for people to use those as they're out trying to share information with others?
Sure, just acknowledge where you got it from, please.
Yeah, so it's a public document, and in fact, the water plant team would really love for you to put things out there and just make sure that you do acknowledge the California Water Plan, Department of Water Resources. And finally, the last question, we do need to run, but there is a question. So you're doing all this regulating of basins, but at the end of the day, is there any authority to stop people from extracting water from private domestic wells or something like, I mean, like how does that work, just regulating the basin?
Yes, I mean as part of the GSA and the legislation that was passed, it does provide additional authorities to the GSAs to be able to, if needed, reduce demand in their area and cut the groundwater production. Currently it's the de minimis amount is 2 acre-feet, so it's not going to affect the little private well owners, but for the people using more than that, I mean, eventually they could be asked to reduce their amount of pumping. Clearly, from what we see in our current groundwater level trends, there's a lot more being pumped than is be able to sustainably be maintained currently. So if you're not doing management actions to help improve that, I mean, the only other real option is to reduce demand.
Yeah,
great.
And I echo that.
Thank you. So with that, it is our practice to end on time, and we did just run a tad over, but those were pretty darn good questions, and we didn't want to lose any of them. If you, any last words from Dan or Mark?
No, thank you. And we'll see you again in July.
In July. So come on back. We've got some more regional reports to share with you. We would appreciate if you're online with us giving our presenters a little bit of a virtual applause. There's a raise your hand function there. So if you want to go ahead and give people a clap. Thank you so much for that. And with that, we're going to go ahead and sign off, and thank you for joining us today. So take care.
Thanks, everyone.
Thank you.